Welcome to all students in finite element method. In finite element method, today we discuss about method of solving. In method of solving, there is elimination approach, eliminate constraints and penalty approach. Now along the boundary conditions, in structure analysis using APA, the boundary conditions are applied because the assembled global stiffness matrix is symmetric, singular and positive definite. After applying the boundary condition, the set of simultaneous equations are used to solve for unknown variables. The different approaches used to handle the boundary conditions are as follows. First, elimination method, second, penalty method and multi-point constraint method. I am repeat again. The different approaches used to handle the boundary conditions are as follows. First, elimination method, penalty method, multi-point constraint method. In elimination method figure, there is two step bars. A step bar having two elements with three nodes, node 1 and 3 are fixed, where R as node 2 is subjected to constraint force P. The overall equilibrium equation can be written as K11, K12, K13, K21, K22, K23, K31, K32, K33, Q1, Q2, Q3. That is equal to F1, F2, F3. Since node 1 and node 3 are fixed, the displacement at node 1 and node 3 will be equal to 0. Using the elimination method of handling this boundary condition is Q1 is equal to 0 and Q3 is equal to 0. The rows and columns corresponding to node 1 and node 3 are to be eliminated from the overall equilibrium equations. So, after this elimination approach, today we discuss about penalty approach. It is an alternative approach to achieve the solution. As per this approach, the rigid support is considered as a spring having infinite stiffness. The support is modeled with very high stiffness. To represent a rigid support, the value of stiffness must be infinity, but an infinite value will create problem in further calculations. Hence, the magnitude of stiffness, which is very large, is considered as C, and it is given as C is equal to maximum term in the global matrix into 10 raised to 4. After this, we discuss about symmetric boundary conditions. A structure possesses symmetry when its components are arranged in a periodic or reflective manner. The different types of summary may be reflective, rotational, axis symmetric and translation. In initial boundary conditions, the type of constraints may be displacements. Symmetry conditions are used to impose symmetry or anti-symmetry restraints at certain points or lines of structural symmetry. The example of symmetric boundary conditions are different. So, after this, we discuss about elimination method. This is the elimination method. After this, we discuss about very important point like elimination method. In 1D element, there are different types of elimination method are used. In elimination, there is applying after boundary conditions, some row and some column is deleted. Applying the boundary conditions, after applying the boundary conditions, we get solution. So, elimination method is very important method. In this elimination method, all types of solutions are found. So, in this elimination method is very useful for our subject in finite element analysis. In this elimination method, there is basic like type of element used in finite element analysis depend upon type of problems to be solved. The problems may be structural, thermal, fluid and electromagnetic. That is, selecting suitable element for particular problem plays an important role in finite element analysis. Elements can be different types depending on the discretization process. In general, different types of elements are one-dimensional element, two-dimensional element, three-dimensional element, axis symmetry or rotary elements. So in this is very important topics like elimination method. In elimination method, modify equation like degree of freedoms 1, 2, 4, 7, 8 equal to 0. This is the equation of 2D truss like element truss and elemental reaction forces. This is the 2D truss development of tables like coordinates table, connectivity table, direction cosines tables. This is 2D truss equations. This is 2D truss. This is the element 2, element 1 and element 2. There is node 1 and node 2. There is 2, 1, 3, 1. These are the node. These are the 2D truss equations. Very important equations. 2D truss equation. There is L equivalent is equal to root of x2 minus x1 bracket square plus y2 minus y1 bracket square. L is equal to cos theta is equal to x2 minus x1 upon L equivalent. M is equal to sin theta, that is equal to y2 minus y1 upon L equivalent. So this is very important equation. This is a 3D truss stiffness matrix like 3D transformation matrix like direction cosines. L is equal to LMN 0 0 0 0 0 0 LMN. This is the 3D stiffness matrix equation. So today we discuss about all these stiffness matrix equation. So thanks all of you.